Hi everyone, it's Mr. Hamilton here. This video I'm going to talk all about how to become a millionaire. The power of compound interest is amazing. Now it's important to note there's no guarantees in investing, but the strategy I'm going to teach you is that just by putting a little bit of money aside, you can easily become a millionaire by the time you retire. So let's check this out and how that works with the math. Suze Orsman is a big personal finance expert in North America, and she said this: the key to your financial freedom in the future is investing when you are young. So if you're young and watching this video, that's a really good thing for you to be doing. So the first question is, what percentage interest rate can I get? You've probably been to the bank and maybe got a GIC in high school as you save for university or things like that. But the reality of it is you can do much better with some things that seem risky short term, but long term aren't really risky at all. So I'm going to look at one specific example, but there it says be sure to diversify. Be sure you don't put all of your eggs in one basket or one investment. But this one that I'm going to show you is one of those good baskets to put your money into. And that is the S&P 500 Index ETF. So there's a difference between ETFs and mutual funds. ETFs are money that you put into a fund that just rides the market. And so the S&P 500 are the top 500 stocks, companies in the United States, the largest ones. And so the difference between an ETF then, what I just described, and a mutual fund is that the mutual fund is managed by a mutual fund investor. And so there's money taken off the top, and then there's extra money that's charged to manage the fund. And they don't typically do as well as the index because the people investing the fund, they might have $2 billion in that fund that they're investing, are more conservative and worried that people will lose their money. So they'll pull their money out if there's any risk in the market, and then they miss the growth that comes after that risk. So talking about this S&P 500 Index ETF, last year's return was minus 12.5%. And so you might say, well, Mr. Hamilton, that's not a good idea. What are you talking about? Why are you saying this is a good interest rate that this will get? Well, we have to look long term. Because if we're talking about becoming a millionaire, we're not talking about doing that overnight. We're talking about doing it over a period of our lives until we retire. So wait, it's not necessarily negative 12.5%. If you look at the last 5 years, the S&P 500 index has grown by 11% annually. It's grown by 16% annually over the last 10 years. Over the last 20 years, it's grown by 9% annually. So that means that between 10 and 20 years, it had a bit of a downtime, but still 9% annually is very good. Over the last 40 years, it's grown by 12% annually, and that's the time frame you're looking if you're a young person, maybe until you retire. So that's very, very good growth every year. Last 50 years, 11% annually, and then the data I have shows the last 70 years has grown 12% annually. So let's use a conservative 9% number. That was the lowest number we saw, and let's assume that we're going to get that on average for every year from when you're 25 until you retire at age 65. So let's read what the question says. How much will you have when you retire at age 65 if you begin investing $300 a month at age 25 in an investment that pays 9% per annum compounded monthly? So what we're going to do is we're going to calculate it with our future value compound interest formula. It's our annuity formula. An annuity is something that we're making regular payments into. The R value is the regular payment amount. The future value is what this is going to become. The I is the interest rate divided by the number of compounding periods per year. And then the N is the total number of compounding periods. So it's the number of years times the number of compounding periods per year. So let's see how that breaks down with the givens that we're going to list here. The R value is 300. We're going to make a $300 a month regular payment. The N is the number of compounding periods. So that means we're going to do 40 years, 25 to 65. But there's 12 compounding periods per year. So 40 times 12 is 480. As I mentioned about the I, it's the interest rate as a decimal though, and we divide that by the number of compounding periods per year. And so that's divided by 12, so we have 0.0075 as the I value. What is the future value? That's what we're trying to find. So we sub those numbers into the equation. You can do this yourself. Some people like to simplify everything in the numerator and everything in the denominator. That's not required. You could put it all in one step. But if you do, you could have that line there, but you get $1.4 million. $300 a month aside from age 25 to 65 at 9%, $1.4 million. That's remarkable. So that means that you would have $1.4 million after investing $300 a month for 40 years. Well, let's look at that from another angle. After we first consider how much we actually invested. We've invested $300 a month, 480 times. And so total, we've invested $144,000. So we almost grew our money 10 times. That $144,000 has become $1.4 million after 40 years, which is an amazing growth. So let's consider the situation starting at age 45 instead. So if you instead waited until age 45 to start investing, how much money per month would you have to save per month, just so it's clear, it's per month, until 65 to get the same $1.4 million, still at 9% per annum compounded monthly? Now remember that /A, the per annum there, that means just per annum is per year. So for this situation, we know that we're trying to find the regular payment amount. So that's the R value that we're trying to determine. The next thing we need to determine is the N value. Well, in this case, it's 20 years, 45 to 65, and 12 payments per year. So that's 240 when you multiply those together. The I value hasn't changed from what it was before. So it's still 0.075. But now the future value is the same as it was before. So we're going to try to get the same amount and determine what that regular payment was to make that. So what I'm going to do first with that equation is I'm going to multiply both sides by I and divide both sides by what's in the square brackets. If I divide by I, what you can see happening here is the i's are going to cancel and then the square brackets are going to cancel. I'm multiplying by I, dividing by the square brackets, and whatever I do to one side, I have to do the other side. So I go to the other side. If I multiply by I and divided by the square brackets, I need to do the same thing on the other side. So now what happens is I times the future value is on the numerator. Those multiply together because it's like the future value is over 1. So it's in the numerator. And then that becomes my equation to solve for R. So I sub the numbers in. I can simplify the numerator and denominator if I want. You don't have to. You could put it all in one step. But the answer is $2,102.75. What does that mean? Well, it means, therefore, to get $1,404,396.08 by age 65, starting at age 45, you would have to invest $2,102.75 per month. That's a lot of money to save every month just for your retirement on top of all the other expenses you might have. So, how do these compare? Well, if you started saving at age 25, you get the same amount as if you started saving at age 45, but look at the monthly payments and how they're different. They're very drastically different, aren't they? In one case, we've made 480 investments. In the other case, we've only made 240. So in total, we've invested $144,000 starting at age 25. But if you start at age 45, even though you've only made half the investments, you've invested over $500,000. Take the 240, multiply it by the $2,102.75. Well, how do these compare? You would have to save 7 times more per month if you started saving at age 45. Overall, you'd invest more than 3.5 times more. Those are some big numbers. So let's see. You've made nearly 10 times your money if you started to save at age 25, and you've made less than 3 times your money if you started to save at age 45. If you're young, start saving for your retirement as soon as you possibly can. It will pay huge dividends for your future, and may be the difference between you being a millionaire when you retire or not, because most people can't afford $2,102.75 per month to save for retirement. If you found this video helpful, be sure to like, subscribe, and hit that bell button because there's another video coming out all about how that money will help you fund your retirement.